Okay, is today the 21st? Yes. Is this date? Right, okay. Yeah? Okay, y'all had a good weekend? No, Megan's like, no, what's wrong? Are you worried about this midterm? Something else? Huh? Oh, you're sick? Oh no, I hope you feel better. Hi, Sadiksha. Hi, Jola. Okay, let's get started with the exam review. So I took a look at all of the responses in the form that you all filled out on Friday to see what you wanted to review the most. So this is what we're going to do. I'm gonna give you like a playbook to try to follow for how to think through problems. I know someone said this in the feedback or in the additional request section. And then these were the main topics that you all wanted to talk about. So 2D lists, dictionaries, and sets. So similar to last review, if you can remember, I'll do a little quick review and then I will give you some time to practice a problem and I'll try to come around and see if anyone needs help. And I'm gonna try to give you more time because some of you said that with the exercises in class, sometimes you spend all the time thinking about the problem and you don't actually get a chance to do it. At least later on you could do it if you wanted to, but maybe I'll try to give you a bit more time and less review today to try that and see how that goes. Okay, so my playbook, I think a lot of people would have the same playbook, is how should you approach these coding questions? So first, I think you really obviously want to read the problem really carefully and make sure you understand it. So the way that you could do this is to look at the examples really closely. At this step 2, you should also really think about the edge cases for the problem you're trying to solve. So think about different cases, think about the inputs and the expected outputs so that you can test yourself and know that you understand the question correctly. And if you don't, ask for clarification, right? So during the exam, just raise your hand and ask me. But really make sure you spend the time understanding the problem before you try to code it right away. The next thing that I would do is write out pseudocodes. So literally write English for the steps that you would take to outline how you would write the program or write whatever you're trying to do. So in a step-by-step program, you know, it's like line by line by line, right? So it's like step by step by step. Try to figure out, given the input data, how you would get the desired output and that data. So if there's a conditional, write if this and write it in English, right? And then indent and write in English, right? So structurally make it correct, but don't use exact syntax. So don't think about the proper syntax quite yet, just outline what you're going to do. And I would suggest doing it in the same indentation as you would in code too, right? Because then that helps you visualize where all these pieces go, even though they're not exactly right yet. Okay, and then after you do this, translate the English you wrote now into code, right? So now make sure you're using the correct syntax. And then once you do that, I know that will probably take you the majority of the time, but then trace your code at the end. So this is really important, I would say, for for loops with tricky indices, but maybe for other questions that don't involve like little tricks on being really careful with indices. If you don't have time to trace it, it's okay, because hopefully you've spent enough time on the other steps to really validate that you know what you wrote is correct. And I've updated the scaling this time so that it's less points lost if it's not correct syntax. So I've tried to learn from the first midterm and make the rubric for the second midterm a bit better, and you'll see this tomorrow once we go over the solutions that for the practice exam that you'll take during lab. So yeah, even though it is really important to have correct syntax, I know because you're doing stuff with pen and paper, right? You're not going to be able to validate immediately that you're doing the right thing, and that's not what you do in practice, right? In practice, you have code. So it's going to be less points that you will miss if you don't get it exactly correct. I just want to know that you know the fundamentals of how to solve a problem with what data structures you need, the for loops, while loops, whatever you need to then create a almost functional program. And if it's not almost functional or not completely functional, you won't be like punished for it. Okay, so let's try running through this playbook with an example question. So if you go to the collab that's linked, and we're gonna have like 4 of these per section, so one on this, one on to-do list, dictionary sets, right? 4 problems that we'll work on throughout the class. So first, playbook. And someone mentioned that they wanted to do the RLE problem, which is the compress, decompress problem that we saw in homework, and revisit this. So let's do that. So this is exactly what it was like in your homework. But now, I really want you to think through the steps that allow you to then set up the problem well so that you can write out the right code for it. And then write out your pseudocode somewhere. And I would say try practice doing this on pen and paper, right? Some of you mentioned you wanted suggestions on how to be better at writing code on paper. It's really the same. You just don't have this immediate feedback of a terminal or whatever. So the more practice you do, the better. But obviously, if you really know the concepts well, it shouldn't matter if you're doing it on your computer or on paper. So try to write out on paper. Let's just try during the whole class today. Write things out on pen and paper. Don't type. And at the very end, if you want to type it, go ahead. I'll give you like maybe a minute warning, and you can use that minute to type your solution and see if it works. And I know some of you have seen this problem before, but if you can do it again completely perfectly, then you know you've gotten it. Yeah? Huh?
We should do this now.
Yeah. So each problem, there's 4 problems. I'll try to give you all like 10 minutes to do them. So maybe like 5 to 7 minutes to do it, and then we'll talk about it. What? Okay, so again, we have 4 problems throughout class today. I'm going to give 10 minutes to each of these problems. 7-ish minutes, you all think about it, and then we'll come together. But let me know if you need help, and I will come to you. Make sense? Okay.
Okay.
Good? How was your... Yeah, what was in here? Do you drive there? Or fly? Bus? Was that like 8 hours?
Sorry.
They couldn't have planned it a bit better. I feel like I would have tried to make it. I'm sure you will. I think you'll be so successful in the whole life. You will. Which is so as long as you have the functions that you can press that are there, you just leave your code as it is. Whoever is in charge of submitting it for that part, I will only create that part and assign that grade to all of you. But there's the form that's due. You have to submit that form by end. I would say just whoever is, if you read the instructions, yeah, so just whoever's submitting the paper. So it's part one. You're working on part one. And that's the first. Yeah, and then fill that out. Yeah. And then share it. Yeah. I know it's confusing. Yeah, you just have to read it. That's what is, I guess. But I know I've got to be with yeah. I'm gonna Yeah. Yeah. Anyway. So like when you're trying to figure out how to write it, yeah, but to figure out the outline of the resources. Yeah. Huh? How's it going? Good? Okay, one more minute. So maybe if you want, put what you wrote down into the collab and test it out. Okay, should we talk about it? Yes? Okay, I see some of you still working, but I will go ahead and talk about it while you finish up. Okay, so this is decompress and then compress. So the easier one is decompress, right? Because you have the string, right? And then the number of times you want to repeat it. So you want to use the accumulator pattern. Probably all the problems I'm going to give you are going to use this pattern where you're trying to get the result at the end, right? So it makes sense you want to use a for loop, iterate over that string, right? You want to look at everything in there to get that information, give you some output. And it looks like the comments here are what I would tell myself in English what I need to do. So use the accumulator pattern, visit a pair of elements in the list at a time. So what you can do is use this range function with the step 2, right? And then I need to figure out at each time the right character and the number of times to repeat it. So identify the character, identify the number of times it should be repeated, and then add that number of characters to the result. And it looks like I need another for loop to do that with range again, right? So then I'm able to get the result I want. And then this is how exactly I would convert the English into code, right? In the same way, if I want to compress it, this one's a bit harder, right? I have this string of things, and there's like a repeat of this one, a repeat of this one, a repeat of this one. I have to compress it and see how many times each gets repeated. So the information that I want to keep track of is the previous character so that I know at what point it changes. And then I also have to keep track of a counter to know how many times that character or whatever has been repeated. So this is information like variables and data you want to create and store to help you with the program that you're trying to write. So you're going to keep looking at each character, and once it changes, take that count, take that character and put it in your accumulated result, right? Does that make sense? And so then if that character has changed, what you have to do is then also reset these counters, right? Reset the count to be 1 and then reset the previous character to be that new character so that you can see when the next one changes again. So maybe you would use 0 or maybe you'd use 1 depending on where you put this code. But ultimately you need these variables to help you keep track of things. So a counter and then the last character you saw to know when it changes, right? And then this might be one tricky thing to keep in mind is once you've traversed the entire list, then you have to not forget to add that last character and the corresponding count. So this is an example of when you'd want to trace the code in the end, right? With an example to make sure that you didn't forget this last step. Because it's very possible that you would forget this, right? But if you trace the code, then you can be like, oh, I caught myself. It doesn't work. I need to add this one thing. So if you were to do like a technical interview, it really matters that you trace that code with whoever's interviewing you and then catch your mistakes, basically debug your code, right? So an example of when you might want to trace it and how it would help you and catch this thing at the end. Okay. Any thoughts on this or questions on this? Okay, but see, sorry, I know you're all looking at it. But see how I literally wrote out all of these sentences in English and then converted that to code? And the comments are a little bit egregious. You don't need all of that, right? But it just helps you visualize how the outline steps then translates into exact correct code with proper syntax. So maybe when you're doing the exam, like do it on the scratch paper, right? And then put your code on the paper in the box, right? Or if you wanted your comments like this, happy to also submit that, right? Like you can also put your code and write out the comments with it too. It's totally fine. But don't make it too messy so it's easier to grade. Okay, let's go to the next problem.
Sure, what did you say?
If you want to, in your midterm, write out the comments above your code, you can do that. If it's just really messy, then obviously it'll be harder to grade. So just try not to make it too messy. But that, if that helps you, do it. By all means, do it. Yeah. Yeah, Monica.
So what's the order of
The order of what? The order does matter in which you put different things. And the order matters because I'm giving you a list, and the output should be the list in that order too. Yeah, I don't know which order you're referring to, but it does matter. The order does matter, yeah. Okay, let's talk about 2D lists. So remember, lists are a data structure that contains ordered elements. So these elements can be anything really. They can be strings, numbers, lists. It can contain immutable things and mutable things. So a list is a data type itself, just like string, integer, boolean, float. Just remember, lists are mutable, meaning you can change them. So you can get the length of a list, index into them, slice them, use the in operator, concatenate them, and iterate over them, and use the accumulator pattern and traverse them, whatever. All this stuff that we've been seeing with all the different data structures we learned, right? So why do you want to use a list? Well, it holds data in an order that's maintained. If you want to change lists, remember they're immutable data types, you can use these built-in functions, append, extend, insert, remove, and pop. And when you take the exam, I will give you this set of functions exactly. So again, if you had to memorize something, maybe you want to memorize this, but it's okay because I'll give you this on your exam, but it's just good to know how they generally work, and if there's something that you forget about the specifics, like the ordering of these arguments or what error gets thrown, you can look it up as if you're like reading the documentation in the exam. Okay. So a 2D list is just a list of lists. So this 2D list looks like this, right? It's lists inside the outer list. And then you can access the inner list by indexing into it. So the 0th element of this list is another list, and it's ABC. And then you can access the values inside this inner list by indexing further, right? So that you can see we're indexing twice to get a value that is a character. So really a 2D list is just a list. But remember, what can you do with 2D lists? Well, you can represent grids. And each outer list, each of the lists inside the outer list rather, is a row. And then each value inside those lists are then the columns you could think of. So it kind of makes this grid where it has coordinates. So a 2D list is just a list of lists, right? You can do everything that you can with lists on 2D lists. There's just another layer of complexity. So what do you really need to know for 2D lists? Really just how to trace or even write a nested for loop. That was the whole point of learning 2D lists, is that maybe you would need a for loop inside another for loop to get all the information in there. So everything you learned about lists is also what applies to 2D lists, right? It's just another level of complexity. But do you really need to understand how images are represented? No. I'm not going to be testing you on that. It was more of an application, like a real world application of 2D lists and like grids. But I'm not going to test you that in like a 50-minute exam, 45-minute exam, right? That's really silly. I think it's more for the projects that I wanted you all to understand how images are represented using 2D lists. But in terms of like trying to figure all that stuff out under like time pressure, that's really silly. So I know a lot of you are stressing out about this in the responses that I saw. So yeah, don't worry about it. I'm not going to give you anything related to images. I just really want you all to know how to trace a 2D list, right? And know how to index into it and see when and know how to work with it. Or to be able to like write a nested for loop for like a matrix that I give you or some data structure that has nested lists. Does that make sense? Okay, so let's try the problem in the collab, which is this one. So this was a problem that was given 2 years ago, and it's just dealing with like reading from 2D lists. So again, try to write it on pen and paper first. I'll give you a minute warning, and then you can put it into collab if you'd like to test it out. And then try the playbook again, right? Read through it, really understand, look at the examples, write out the code in English, right? Pseudocode, and then make it syntactically correct, and then trace it if you have time. You're good? Oh, you need a charge? Oh. Huh?
Okay.
You're good? Okay.
And it's two different shorts that you remove UTVs as a celebration. Or both of them? No, there are two. There are two. Same function when you show them. These are examples of functions. Okay, goals.
Okay, one more minute. And then again, use this minute to put stuff into Colab if you'd like to test things out. Did I give you enough time? I don't know how much time passed. It's like 5 minutes. Okay, how is that problem? Fine? Good? You could do it? Doable? Okay. So let me just show you all the solution, and don't worry about this, I will post it later. But what you probably know is that you're going to use an accumulated pattern. I think all of the questions are going to be like this. And you're going to iterate over the 2D list. So if you want to see everything inside, you're probably going to use a nested for loop, right? That's the whole point of giving you problems like these with 2D lists, is that you can figure out how to traverse it most often than not, right, using a nested for loop. So making sure that these conditions are right and where they are in their indentation, right? So if anything is less than 4, remember also, this one's a little tricky too. You have to copy this list if you want to do it this way. You don't have to do it this way, but if you want to, you could copy it, right? Iterate over the copy and then actually mutate it here and mutate the original one. Yeah. Well.
Are we using copy due to the fact that by removing page 1 to aspect the current?
Exactly, yeah. So you never want to mutate the list as you iterate over it. So one trick is to make a copy, iterate over the copy, and then mutate the original one. Go back to the question. This question. This is in the collab. Yeah. Go, there's a collab link to, yeah.
Thank you.
Yeah. Okay, and then knowing when you want to append what to the result, and the condition being the right one, right? And then returning the result in the end. Okay, again, I'm going to post these later, so don't worry about getting them. Just try to listen to me and you figure it out later. Okay, let's keep going. Yeah.
How did you account for edge cases in the question in your solution?
So this one I gave you, you can assume that everything is good. But I also gave you the example of like empty lists, right? So yeah.
Yeah, I was thinking of empty nested as well.
But it still works, right? With the empty list. Okay, let's talk about dictionaries. So a dictionary is an unordered collection of key value pairs, right? We already know this. It's known as a map because it literally maps keys to values. So in our example here, this dictionary looks like this with these keys and these values. We already talked about this before. So remember, keep in mind the valid data types that are allowed for the different data structures. So keys have to be immutable, meaning strings probably, but it could also be integers, floats, booleans. You cannot have a list as a key to a dictionary, right? And then the values can be anything. It can be mutable or immutable. So if you want to mutate a dictionary, there are methods that you can use, right? And these are the ones that we've seen before, right? So again, I will give you this literally on the exam. So if you want to look up what they're for and how to use them exactly, you can do this or see this or reference this. Okay, so just keep in mind nested dictionaries are just dictionaries of dictionaries. You can do everything you want with them that are the same for dictionaries, right? Index into them, iterate over them, mutate them. So now let's do this practice problem for dictionaries. So in the linked collab, Daniel. Okay, here, this next one. Okay, so I'm gonna give you maybe 5 minutes for this. Sorry, I feel like I'm always racing time. But then we'll talk about it quickly. And then there's one more problem I have for you all. All right. I know it's not a lot of time, but one more minute. So if you want to type your answer into Colab to test it out, go ahead. Okay, let me show you what this solution is. So it looks like this. And you just have to check, right, if the item is in the dictionary before you actually add that value to the total. So again, we're using the accumulator pattern, right? So you're iterating over your shopping list, checking if that item is in the dictionary. If it is, then add that cost, right, value to the total. Okay, one more question for y'all to try with sets. So remember, sets are an unordered collection of immutable things. So integers, floats, booleans, and strings. And what's good about sets, or unique about sets rather, is that they only store unique things. So characteristics, they cannot have duplicates. They're unordered, so you can't index into them and slice them like you can with lists or strings. And they're immutable. So remember, these are the different built-in functions we've seen: add, remove, pop. So this is what I would give you on the exam exactly. So you always have this as a reference. Okay, let's work on this last question that deals with sets. Okay. I think this question's a little bit easier. So, 1 more minute. And I know we're going a little over time, but last thing is just reminders. Okay, maybe 30 seconds. Okay, so the solution for this one is this, right? So using the built-in set method, right? That just makes a iterable thing unique, or a list of unique things, basically, or a set of unique things. And then you can iterate over that set, right? And then do whatever you want with the things inside there. Okay. I will post these later, so don't worry about getting them now. But as long as you try it and you see the kind of questions that I would ask you on the midterm. Okay. So some additional questions that came up was review the Connect 4 problem from lab. I didn't want to spend too much time going over that in class. So yeah, I will link to this collab here that has a solution to the detailed code. The code with detailed code comments for the different parts of the functions. I know this is a really tough question. So yeah, if you want to reference that and use that as practice to prepare for the midterm, go ahead. And then, yeah, the solution I will post on the collab. So for the RLE problem that we just solved today. And I think that was me trying to address all of the requests on that form. So hopefully I got everyone's requests. So yeah, just a reminder, this tech challenge is there, and then midterm 2 is on Wednesday, so therefore there's no new homework tomorrow, there's no new project, no quiz this Friday. That's all gonna resume the following week. So yeah, next week on Monday, the next part of the project will come out. Tuesdays when homework will be released, and then Friday there's another quiz. Okay, and then project 2 part 1 is due tonight, so don't forget it's going to close when it closes, so no late submissions. And homework 8 is due Wednesday. So midterm exam 2, everything you've covered except for tuples. And then tomorrow you will do a practice exam. Are you all listening?
Yes.
Okay, so practice exam during lab tomorrow for the first 50 minutes, right? And then we'll spend the last part of it, like 20 minutes, whatever, 30 minutes, going over the solution, and I'll show you the rubric too, that I will grade you on. So it'll be very similar for the real one too. Okay. And then if you do better on midterm 2, I'll replace your midterm 1 score. Step, don't forget, coming up is almost due. And then grades, the letter grade that you have for your midterm will be available at the end of this week. I'm just waiting for the project stuff to be finished grading. So yeah, if you also, again, want to know ahead of time, just come ask me and I have it all in my computer. And then if you want to reach out to the Googler TAs or other career coaches that are people that work at Google that want to help you all, you can book an appointment with them to do it virtually. So yeah, don't forget that that is a resource for you all as well. Okay, and then let me know if you have any questions. And I have office hours later today at 3. Okay. Hopefully that was a good review, good way to practice for the midterm. But yeah, let me know if you have any other questions, okay?